I'm extremely glad to present this most challenging case study of mine, which was designing a Palki for Vaishno Devi Yatra at the shrine. A number of people who are elderly would want to visit the shrine, but they can't actually climb the arduous journey of 17 kilometers. So they actually prefer a Palki. And the Palki also is carried by 4 porters. And for them, it's of course a tough ordeal, but that's also their livelihood. These are the challenging aspects we looked at when we started this journey. This journey of design was a very collaborative one. We had the shrine board officials who were great supporters. We had the secretary of the porter organization, very, very supportive again. We had the principal scientific advisor to the Prime Minister's office, Mr. Chidambaram, who actually was approached by the governor with a request to do something for the porters because it's so tough for their journey to carry pilgrims to the top. And of course, we had our wonderful collaborators, our educational institute, NITI, which is our neighbor in Powai, who helped us with the study of ergonomics in a very great detail. And we are very, very grateful to IIT Bombay and the design school for the wonderful support to take this project forward. So here again, we used our 7 concerns of innovation as the mandate to start the process. And our first concern, which is the cause, that is, we stood for a cause to design the Palki in such a way that it is lightweight, so that the only challenge, the only requirement of the porters was, yaar, ise halka kar do, make it light. And once you make it light, everything falls into place. They're able to travel easily, they're going to able to take it faster. All their requirements are sorted out just by that one champion cause, which is to make it lightweight. So here, for example, the interesting things are there, how this Palki is a phenomenal design. So this particular design, for example, is a design where the porters are in a single file. You don't see these type of single file porters in other locations, but this is very unique to this location. And we'll unravel all that while we go ahead in our journey. Another interesting thing is about this wonderful mechanism of putting the wooden pole on which they carry is tied with this string, and this string actually does multiple roles. It acts as a shock absorber, it acts as a locator, it acts to support the different heights of porters, and it also acts to turn. Look at these wonderful small innovations which the porters have done in the current Palki. The current Palki has been evolved over the years, and they've got multiple details in this, and that was the biggest challenge for us to unravel. And we unraveled that one by one while we built our prototypes, and I'll take you through that journey. It all started as a student project, and we designed the Palki for Ajanta Caves. So this was a project again from a Master of Design thesis project, and we of course designed the Palki there. And here it's interesting that the porters are actually next to each other. You can see one of our colleagues when we went to study over there sitting on the Palki, and this is again a different terrain. We learned that different terrain needs different type of design. Different distances to be covered will need different type of design. Very interesting learning. And different pattern of rush, how many people are there, needs a different type of Palki. So these small details helped us to understand various aspects. The challenge in the Ajanta project was that the porters had just put 2 poles on a current wooden chair, and they would take this to the caves for supporting the pilgrims. But then these wooden poles would shake, the chair would shake, because the chair is not designed, the wooden chair is not designed for this purpose, right? And when they're carrying people, the nails are coming off, the screws are coming off, and the patrons are feeling very uncomfortable, and of course the porters are not very good because the chair is pretty heavy. So we said, okay, let us relook at the design, and we tried to design a chair in stainless steel, and so that we used very thin stainless steel pipes to make it lightweight, but we exactly copied the design as it is, and we took it for our trials. This is a student project which started very creatively. The student had some phenomenal designs with a round pipe and 2 legs. But I must tell you the story of how we built that prototype. And when we took it to Ajanta Caves and we tried with that first design, the pipes which were the leg rests actually went into the thigh of the porter. So then we realize how important it is to understand how the Palki evolved, and that's how we came up with this simple design, actually a copy of the current design, which works so well in the terrain as well as the distance. Here you can see that the pole is at the handrest. Then we went to Elephanta Caves close by in Bombay, and at the Elephanta Caves we found again another surprising thing. The same Palki, similar Palki was being used, and the pole was attached to the floor of the seat. And then we said, wow, what a design intervention, because Elephanta Caves, the rocks are steep. They don't need the center of gravity of the person to be low because the distances are very small, and they want good clearance, hence the poles are attached to the bottom. See how critical the terrain is for designing the Palki, and that was a very interesting lesson for us. And that also was again one of our teaching assistants project where we created the Palki for Elephanta Caves. With all this at the back, we had this wonderful learning from the Palki we designed for Ajanta. The learning is the Palki needs to be maintenance free, very critical, because the porters don't have much resources, poor things. They are mandated by the government to charge very minimal fees, but the government doesn't give them anything. That was also another challenge for us to see that we do something for them. And it had to be simple so that they can easily operate. And we have to keep the porters as our primary users. We can't say that the patrons should be comfortable. They should be comfortable, but our primary user would be the porters. And of course, as I kept on mentioning, the terrain and the surrounding environment will be very, very crucial for our design. And the Palki, of course, needs to be low weight as possible, and the materials and manufacturing should be in such a way that there is no maintenance, and local vendors should be able to manufacture, and of course should be able to repair. So these are the key learnings which we got from the Ajanta project. So then we had this wonderful visitor for one of our Tech Fest shows in IIT Bombay. The design school in IIT Bombay always puts up its exhibits during the Tech Fest so that aspiring engineers who like design can come back to our school to study. So it's like a pitch for there in the Tech Fest exhibition. And we put such an exhibition, and we were very fortunate that during that year, the organizers of Tech Fest invited Chidambaram, who was the principal scientific advisor to the government of India, and he was known to us earlier on other projects. So he visited us in our stall. And he was so thrilled to see the Ajanta Palki, and he immediately said, we would want you to work on the Vaishno Devi Palki also. So that brings us to our major focus of the project, of the context. So here we realized that the Mata Vaishno Devi shrine is, the trek from Katra is around 17 kilometers. So that is a big challenge. We studied the aspects, and we studied the current Palki very carefully. Every detail, and what happens, where it breaks, what happens, all the studies we did. And of course, we also went on multiple trips with the porters, and of course the porters dexterity, their movements and their agility and their basic way of life was very inspiring to us, and we were focusing on that aspect too. And then we realized that they also had teams. So 4 of them would form a team, and they would customize the Palki to their requirement and go to a local vendor and get the Palki made. So now, students, all of you have to realize that we are now in a very difficult terrain. A customized Palki for a team of 4 people with a particular height would customize that to their requirement. And here, the requirement is, if the person is tall, the Palki is longer. If the person is short, the Palki will be shorter, right? So those challenges, we didn't realize at that time, but that we realized, quite later. Again, we kept on repeating this very interesting aspect that one Palki will not fit all situations, and that is the whole focus of the context. And here we understand that, it's of course the people, the type of communities which do this work, the terrain and the location, the distance and the environment. all these factors become very critical, and we did explain already how critical all these are. So here, for example, it's important for us to study how the porters actually lift the palki, and how much rest they take while they go forward, and what type of situations they encounter. They shift the load from one shoulder to another during the journey, depending upon the load of the patron. If the patron is 150 kilos, they will shift the shoulders much more frequently. If the load is lighter, they will shift the shoulder less frequently. But the cue comes from the first porter. The first porter, because he's on the uphill slope, will actually shift the shoulder. The next one will shift the shoulder. The third one will shift the shoulder, then the fourth one will shift the shoulder. So that's how they have the cue, which will go one on top of the other. And the shift is synchronized. And they have a good understanding. They are all very good friends. They always go together. So this team becomes very, very critical for the access. And we have a multi-level user, as I rightly told you. We have the porters, who are our primary users, the pilgrims, who are our sort of secondary users, and we also have a lot of tertiary users for whom we have to be very careful with, which is the local fabricators, and of course the shrine board, which will organize the distribution of these palkis. So with that, we had this wonderful understanding of the current palki. We did a good ethnography study to understand the porters. We made friends with them. We went to their village. And they did tell us a lot of interesting situations. And one very interesting thing was that when the government made a road, motorable road, they all went on a hunger strike. And that's where the governor had approached the principal scientific advisor that, why did you improve it? Because they really want to use it as their livelihood, and we can't spoil their livelihood. And again, I would like to tell you a very interesting anecdote here, that they work on 6 sigma level of quality. That is, no incident at all of failure. And already one of the helicopter, crashed in Vaishno Devi, and we lost 5 people and the pilot. So you can imagine, the palki has no accident record, no deaths, and the high-tech helicopter which takes porters to Vaishno Devi already had a hit. So we can really see how effective traditional systems are, and we need to understand those aspects also. The third important aspect is, I've been telling you all about the insights from the start of this case study, but we need to consolidate all the insights as a comprehension. We have to get all the insights right. We just mentioned of how critical it is, the turning radius. You'll be surprised that when we designed our first palki and we failed miserably, we failed at the place where people were turning and they were hitting each other's legs because our distances was not right. So you can imagine how complex the situation is, and the distance between the porters is decided by the height of the porters, and it is their private palki. It's not a public palki. So that's the whole challenge, that they know which palki to take and how to take things forward. Then another important issue about the palki design is, I can't make it very high-tech or very costly, because their economies is depend upon that, and they will not be able to purchase this palki. So either we give it for free, or we give them at a very good price of their current palki. So current palki is made out of GI pipes, the locally available pipes, locally available welder, local available bending, right? So it's very, very cost effective. So now if I use industrial processes, how can I give them very, very high quality, lightweight pipe, use bending in such a way that it is going to last longer, and of course weld it together so that it can really be repaired locally too. So that is a big challenge we learned from our first insight. And then of course we have the second insight of how do we take care of the fatigue which happens with the palki. While they keep on carrying the porters, the material goes through a fatigue cycle. And so we need we have to choose a material which can be good for fatigue. And I'm very fortunate that I somehow like stainless steel a lot. I've been working with stainless steel earlier. So blindly, it came to my mind that I could use stainless steel. A number of people would complain that why did you choose so early during your insight itself that you like to use stainless steel pipe? But somehow it came to my mind that people use stainless steel for utensils. Even the poorest of the poor would buy a stainless steel bowl, right? So we said that would be a good material choice, and somehow some of these things we do as insights, and we just use ideas from there. And of course, I told you about this rope, how beautiful the rope is. And tell me, if the rope fails after 4 years, it's potentially very risky, right? That's the place where the main load is coming. So see how culturally the Palki is designed and maintained. The rope is changed annually during the festival time, and at this particular time, the porters religiously have to put the new rope. And the shrine board does a ceremony in the temple, at the Mata Vaishno Devi temple, and this rope is given to the porters. So look at the level of trust, level of belief, and level of comfort and maintenance proof for such type of interesting rope in the Palki. And of course, the biggest challenge was the seating posture. We realized that that posture and the height at which they sit is extremely critical for the balance of the Palki. If we raise the height, we're going to be making it very unstable, and the porters will have difficulty in maintaining the balance of the Palki because it's high, right? It can topple. So that height of the patron was very critical. The slope of the seats were very critical. So that insight also we gained from there. And of course, we had to also see that it is maintenance free because they don't want to spend unnecessary money repairing it. So with all these insights, we also studied their, musculoskeletal discomfort, the type of problems they get on their shoulders because of the load carrying or constant load carrying. And I'm very fortunate here that we had this wonderful team from NITI, the director of NITI, Professor Karuna Jain, and the senior professor Rauf Iqbal, and his research associates and the students supported us in this study where they evaluated all the aspects, they measured all the dimensions, body dimensions, as well as the heartbeat and their basic physical fitness to understand what will happen when we do a new design, will this improve? So that study was very effectively done.
Sir, so looking at the image, I wanted to ask, do they use any cushioning for their shoulders?
Yeah, as per their comfort, they use a towel, they use a shawl, or they sometimes use a large blanket also to cover. But we now know that because of the heavy loads, the load is not a normal load; it's a very heavy load, and because of which the body reacts to that load by small deformities or adding dead skin. So those type of things can happen to the porters. We now can look at the advantages of the Palki, the problems the Palki poses, so that we now know what is what. The Palki, of course, the current Palki is extremely heavy. It ranges from 38 to 70 kilos. And that's specifically happening because of the available raw material there. They just pick up the water pipes, which is the GI pipes. And no guidelines for maintaining uniformity of making the Palki, which is at that time we didn't know, but it is because it's customized. And why should it be uniform, right? Customized is much better than uniform design. The porters actually take the pilgrims to the top and they have to bring them back. The total journey is about 28 kilometers, and in a day sometimes they do even 2 trips. If there's a lightweight person, but if it's a heavy person, they generally get very tired. So that is the up and down journey, and it generally takes around 4 to 4.5 hours one way. And due to the heavy load on the shoulder, I told you, they shift the load. So you don't need to say that, oh, we want to distribute the load, because if you distribute the load, it's much more difficult to carry. People generally carry loads only on one shoulder, and then every 5 to 6 kilometers, the porters take a break. So generally in a journey, they take at least 3 breaks or 2 breaks, and that's how the issues happen. And now looking at the problems, the heavy weight gives them serious health issues. They have problems in the knee, they have problems in the shoulder, and of course, they go through some pain also. And the seat design, for example, there is, basically from the pilgrim's point of view, it's pretty hard. They just have a thick blanket on it, and hence it is very uncomfortable sometimes for a long journey. And there is mismatch in the dimensions of the existing Palki. From the ethnographic study which we did, because they were not very well aware of the seat dimensions. There is of course serious ingress-egress issue, because there was a pipe on which they had to step up and then sit in the Palki. That was not very conducive. And then of course there was issues of stability of the Palki, because it's pretty hard, and when they would weld, they would have little deformities, and that could be a serious issue. So the critical insights was, of course, to reduce the physical strain by reducing the weight, increase the user comfort as well as the safety, and make it culturally sort of consistent and aesthetically pleasing. This is an interesting check which comes from our design background, and of course a system not to destroy the livelihood of the porters. I was very happy that I worked closely with our humanities department, and we had a sociologist who would work with us and keep on pointing at how important it is to keep people in the project and not look at only technology and solutions which will be only technologically oriented. So here with this, armed with this strong study and the insights, we came up with our 4th C, the check, where to get a clear direction of what we should do. Should be lightweight was, of course, priority number 1. Should be maintenance free was priority number 2, and should be manufactured locally and should be repairable locally is priority number 3. And of course, to ensure safety and the patrons as well as the porters was priority number 4. With these type of 4 strong checklists, we went forward with our design directions and ideas. So as usual, you'll be surprised that we used a plastic chair in our first design. Why did we do that? It's very interesting that design, when we start design, and here remember my students had already passed out, the Ajanta Palki student. So this project was completely handled by me. The earlier projects I was showing were all done by students, and we take the student project to market. Here the project was being done by me, and I was always fascinated by a plastic chair because comfortable, right? It flexes at the back, there's a good lumbar support. I said, why can't I use the same plastic chair on the Palki? So we use the same plastic chair, and look at the design details. We of course reduce the number of pipes. If you have to reduce the weight, right, you have to reduce the number of pipes. No rocket science here, reduce the number of pipes. And of course, made a stainless steel pipe instead of the wooden log so that it can become lightweight. And this was our prototype number 1. And of course, we did multiple like studies of where they will hold, how they will go. And we made a prototype of the design and then took it to Vaishno Devi. We had 2 prototypes over here. The second prototype was, I call it the helicopter design, where we felt that putting the porters inside the pipes. Remember the second and the third ones are enclosed in pipes. Didn't look right to us. We said they should be at least feel free. So we used round pipes there so that they are free, and that we call it the helicopter design because it's got a round canopy type of thing. And in that design, we also went ahead and built a prototype for that. So with these 2 prototypes, we went and met the CEO of the Shrine Board. Again, a phenomenal bureaucrat, Mr. Sahu. He gave us ample time and we could discuss all the details. And of course, when we met the porters actually were very happy to see the prototypes, but they said, "Ye chalega nahi, this won't work." So both the prototypes failed miserably. The first one which I showed, they said, "Ye kursi to 2 trip mein toot jayega." Because just remember the load which people are carrying, 14 kilometers down the road and so much of movement, the plastic would just break within no time, and the screws which are holding the plastic seat would just break. Right? And on top of it, some of the pipes which are there, they said these pipes we need very badly for holding on to it while we move the Palki from the floor to the top, and you remove that pipe, how are you going to take the Palki on the... So very interesting insights. So we took those insights, and the other second prototype, you saw the one which was the curved one. We were very surprised that it just didn't work at all. And when the porters lifted the Palki and with the load, the Palki was actually swinging so much that it was difficult to walk also. So in all the design journeys, sometimes it's important to try. And such type of designs, we always try to see how things work. And we did try and we failed. And we went back with a lot of learning and designed our third prototype, which we built. So here I like to introduce you to the pitfalls of the innovation journey. We call it the valleys of death. So here, for example, we did the design, we made the prototype, we failed, so we go back to design. So design is an iterative process. You check, you come back. So here we designed our third prototype. Here you can see how we built the prototype. This one now had integrated steel chair. It had pipes, full length pipes, so that there's no gap. And we took this, of course we had handles which are made in a different way, and we took this prototype back to the field for trials. In the earlier Palki, we had this structure where the footrest is low, but you have a pipe. So when we built the prototype 4, we raised the footrest up, so that when you go in and sit, you're not getting a pipe as an obstruction, because people wear saris and all. It was very difficult for obstruction. So there was less good leg room, and your luggage was also under your seat, and you get good support. And then when we tested, what happened, Vaibhav, can you understand? When you raise the footrest, what will happen?
I think the one who is traveling gets more comfortable having the leg raised.
But that comfort, like for example, if you sit leg raised, the comfort is of course there, but even with the leg round, nothing will happen. What do you think could be the reason that we failed actually by lifting the footrest?
I don't know if it's because the footrest is raised, but it's just a very thin space you're putting your leg on. So all the pressure will be at that one specific region, and that is where the footrest won't be very comfortable if you're just keeping your feet on it for a very long time.
That is the whole challenge with all of us. We are only bothered about the person who is actually sitting. We are not bothered about the porters or the safety of the person sitting. When you raise the footrest, the center of gravity went up. When the center of gravity went up, the Palki became more unstable. So the porters laughed at us. They said, this is not going to work. You have to take it back. So that's the interesting story of how each component becomes very, very critical. And of course, we compared some of our own prototypes to see how the heart rate is improving, because we reduced the loads quite a bit, and we also kept on working at every prototype. We kept on checking the heart rate while resting, the heart rate while carrying, and of course the heart rate while recovering. Well, they take rest, right? So during recovery, we tested all that, and we of course compared our prototypes, and we saw how our prototypes are improving. So from here, we then removed the footrest. See, in prototype 5. But then here, my collaborators Niti came and said, Professor Chakravarti, you must have a headrest for the patron. It is so tedious for him to go, and then he has to get a headrest. So we created this stainless steel headrest, and we went with prototype 5 to the field. When we went with this prototype, the porters were amused with the design, and they actually told us, sir, what are you doing? We actually have to work hard to wake up the people who are sleeping, and you're giving them a headrest. So this is completely unacceptable. You have to take this off. So we went to a local fabricator there and chopped off the pipe from the top, and then of course it helped us to reduce the weight by another 2 kilos. It was very, very valuable for them. The porters clearly said that the patrons should not sleep, and they should not be given a headrest, because headrest can make them sleep, and when they sleep, they doze, and when they doze, the Palki can topple. So very, very interesting insight again. So we went back to our design stage. We told our partners that it's not possible to have a headrest, and we finally designed our Palki, and we went for our first pilot production of 10 numbers, right? And this pilot production, of course, the students in NITI were trying out, and we had multiple tests they did with the headrest, without the headrest, in their studios in NITI. They had wonderful machines at their end, and of course we took the prototype to the field, and the 10 prototypes were given to them. We tested the single prototype, then only we made 10. We tested that with the Shrine Board officials. This is the testing of the Palki, the final one. We were quite convinced that it will work. We made 10 Palkis with lightweight stainless steel pipes, and we supplied it to the Shrine Board from Delhi. We manufactured in Delhi, so it's easy to transport. And look at those dimensions on circles. These are very, very critical dimensions for us to maintain the heights and the distances between the porters. And with that distances, now I must tell you something which I have not told anybody much, that our Palki failed the second day. After 4 trips, the Palki broke at the same place where the earlier Palki was breaking. And it broke much faster then them. So after all these prototypes and all this learning, we still failed on the strength of the stainless steel. Remember, I was telling you I was very, very happy with stainless steel, and I knew from books that stainless steel is 5 times more stronger. It gets stronger by fatigue. When you keep moving, the stainless steel gets stronger. We know that also. But here, the failure was at the welding joints. You know, Dr. Ketki Bapat, who is from the principal scientific advisor and direct project head for us, she kept on telling us, Professor Chakravarti, you need to do a structural analysis. But I somehow, was so confident of the stainless steel material that I didn't get it done. So after this failure, I went to my professor, Professor Yogesh Desai from the civil engineering. He gave one of his best PhD students to do the analysis. And when we did the analysis, there it is. All the red members you see are, loads which will not work and they'll fail. And our Palki exactly failed at those places. See how it's so important that you can't go with your hunch. You have to go with data. You have to go with engineering. You have to go with structural analysis to take any of your projects to the market. So that was a very interesting insight. And then we went back and then we designed the next one. The bottom pipes were made a little bit more larger diameter. The top pipes were the same diameters, and then it also was considered to come out as a boat, so that the whole pipe is one single pipe, and we removed the stress points in the corner. And this is the improved model, and you can see the improved sections also. And this is the comparison between the structurally evaluated design, which is the one on the far left, and the one which is closer to you is the old one. So these are the load points which are there, and these load points actually were the ones which were failing. And when we designed the new one, we completely took, there's no point, it's not going here, it's completely going to the front. So when we went to the front, the load was well balanced, and we increased the diameter of the bottom pipe over these pipes. So there are two diameters, and that actually worked well. And then it was structurally validated, and we made quick drawings of this, and we immediately sent. So once we did the design, we had to quickly fabricate the Palki. So we actually built the Palki in our product development studio in IDC Bombay, and we're very fortunate in Bombay. Now here, it's a very important thing I want to mention, that your ecosystem for innovation has to be very good. In Bombay, we are very lucky that we got very, very good quality welders who actually work in companies outside. So we went to one of the companies, requested one of their welders to come and weld for us. He finished his shift at 7 o'clock and came in the night and welded our Palki. Because remember, welding has to be very good. I was mentioning in the earlier time also. So here we have this excellent welder who welds pressure vessels. Pressure vessel, when you weld, you have to weld without even blowholes. So he's this excellent person, and here we finished all our prototype, and we took this for testing, and it was there was no problem at all. We used it for 10 days at the Vaishno Devi shrine, and this was very good. We built 5 times factor of safety in this. The Palki was very good. So here again, what's interesting is we had constant meetings with the principal scientific advisor's office, and they have a method of actually bringing in experts to evaluate. So once we did all this design, they called a PRMC meeting. It's called Project Review and Monitoring Meeting. We had eminent members in the committee. The members were very, very experienced in multiple fields. We had Dr. D.N. Badodkar, who is an associate director at BRC. Then we had Dr. A.C. Rao, associate professor at the ICT Mumbai. And we had Dr. V.M. Phale, associate professor from VJTI Mumbai. With these members in the meeting, which was called for by the principal scientific advisor, I had to quickly build my presentation and take the approval. Then on it will go for mass production. So here, for example, I made a wonderful initiative. I invited all the porters from Vaishno Devi to stay in our hostel in IIT Bombay. They came down and they, of course, helped us test the Palki, tell the people that they are happy with it, and that's how we could finally, get the implementation done. To the everlasting credit of these 4 porters who stayed for 3 weeks with us, we had valuable insights from them. And we also learned some very interesting human aspects where they said, like the patron is God for us. We take great care of them. Even if the palki breaks, we see to it that no harm comes to our patron, and we bring them safely down, even with a broken palki. So those type of insights are very, very critical for us. And here we have, for example, the comparison between the old and the new. The material, of course, is much, much more stronger. We had used stainless steel 304 grade. The weight has been reduced to 34 kilos from nearly 65 to 45 kgs. There is, of course, very, very good longevity because of more factor of safety. The load carrying capacity is also pretty good, and of course the product looks much, much better after the redesign. And the handling space for proters is very spacious in compared to the earlier one, and the maintenance is generally half yearly, and in our case the maintenance is not needed at all because it's stainless steel. There's hardly any painting needed, and the porters were extremely happy. So here, when we compared the old and the new palki, we realized that carrying uphill, the heart rates were pretty low, and of course downhill low. It's not rocket science, right? If you reduce the weight, the heart rate is going to come down. So, but still we had to test to evaluate our situation, and the porters' feedback was phenomenal. Their resting, every part of their body was feeling better when compared to the earlier design. And some of the key salient features, as we clearly said, that we reduced the weight to 34 kgs. Even a 1 kilo weight reduction is fabulous, but we clearly reduced by 10 to 15 kgs, which was great. It is durable, and it is maintenance free, hence there is no cost involved there, and the porters are very happy with that. And there is much more comfortable seating for the patrons because we used much better ergonomic seat design at the same level as theirs. There's a possibility of manufacture by local vendors by training, and of course we had enhanced safety by ergonomics and engineering design. So with this, we are very, very fortunate that it came in the papers that IIT Bombay and NITI together worked on this project, and it is a fabulous design. And this was noticed by the chairman of Jindal, because when his mother went on a trip to Vaishno Devi, she requested her son to donate 100 palkis to Vaishno Devi. So see how wonderful such a thing can happen. So we immediately got an order to manufacture 100 palkis, and that is our mass production. So we went to Jindal factory, and very interestingly, Jindal CEO was following up regularly with us ki palki jaldi se de do, because the owner of the company wants the palkis. So we created 100 palkis, and look at this wonderful manufacturing excellence in the Jindal factory. They were very, very good machines for bending of the pipe. They were excellent fixtures designed to have the palki in one straight line so that the dimensions don't go haywire. And you can see these well-designed fixtures, because when you do something in mass production, you need to be very careful. This is a slide I'm showing where you have the headrest which was removed. This is the earlier one. This is the first pilot production where we produced 10 numbers, and we sent it to Vaishno Devi for trials. So we are very happy that Jindal produced around 100 palkis, and they shipped the palkis directly to Vaishno Devi. And we come to our seventh concern for innovation, which is the connection. Here, for example, we had this wonderful ceremony at the Shrine Board where they were actually trying to distribute the palkis to the porters, and we have this very, very happy porters sitting over there looking forward to get the lottery, because there were only 100 palkis and there were around 600 to 800 porters who wanted them. So we so there was a lottery which was drawn, and we gave the palki because it was donated, we gave the palki at half the price so that we can use that price to manufacture more palkis. And the porters were very, very happy to buy these palkis at 8,000 rupees, and currently they make their palki at 18,000 rupees. So that is the level of comfort. The project was initiated by NN Vora to begin with, but by the time we could design the palki, Mr. Satyapal Malik became the governor, and he was very, very happy to come and actually sort of distribute the palkis to the porters. And we presented him with a small palki for his office, and of course the porters proudly demonstrated the palki to him, and they could distribute all the 100 palkis, and we can see the porters proudly using the palki in Vaishno Devi Yatra. So now it's a very, very rewarding experience that we could make multiple prototypes, not give up. And finally, the porters are extremely happy. The patrons are very happy to sit in this gleaming stainless steel palki. They feel comfortable and they feel, sure that, the palki is going to carry them safely. And of course, the porters are very happy because it's actually less effort for them, which is their livelihood, and it's a daily activity for them. And, with this, we are very, very grateful for our complete collaborative team, my colleagues from the Design Innovation Center, my colleagues from the IDC School of Design, IIT Bombay, then NITI and the Shrine Board and the PSS office for this wonderful initiative that we could reach the stage of implementation and take the Palki to the people at large.
So why you prefer to have the shoulder rods to be of wood and not stainless steel? It could have the
Gaurav, very good question. When I did the rod in stainless steel and we took it first time, the porters were very uncomfortable. And then in some of our documentation, I noticed that when there is a stainless steel rod, the stainless steel rod material is not soft. The soft is a very different term here.
It could be covered with sponge or something.
I tried that, I covered with the PVC, but it has something called a shock absorption built into it, and the whole length also was important. So, so then we said, okay, let us not change too many things, and we kept the log as it is. So it's very interesting that I had this, memory from my design school days where there was this wonderful bullock cart designed in metal, and the pipes were made of metal. And actually, in the traditional bullock cart, there is a rope which puts the wooden log. But in this case, they bolted the steel pipe to the frame, and the bullocks actually died after 3 days. So it is that type of load which can come on this. So keeping that in mind, I said, though using stainless steel pipe with the rope, and I was not bolting it to the structure, I still, with that memory in mind, I said I will not change the wooden rod which will be there. But, we need to really study whether that can, be changed so that the weight can further reduce by 2 to 3 kilos.
Can the carrying pole be replaced by bamboo?
We didn't try it, but I think bamboo material will be more flexible, so it won't work. Whereas this pole is seasoned wood, which is very good to carry and has got very good stiffness. So we didn't think about it.
So have you ever thought of other sustainable options that you can use instead of the wood, or have you thought about it?
Yeah, again, very good question, Sneha. So when I actually started, you remember I was very focused on maintenance. And then also what happens is when you have industrial processes, it's very easy to take it to market. So that actually prevented me by thinking. But once my product became successful and I told everybody, a lot of people kept on asking me, like, why did you use cane? Why did you use bamboo? And then it kept me thinking. So I went back to my drawing board, brought cane from all across the country, tested cane on the universal testing machines to find out the right cane for this product, and then we built a Palki with cane, and I'm extremely happy to mention that our weight reduced by another 10 kilos. So now we have a Palki which is as good as the stainless steel Palki, but the weight is 24 kilos, and we have now sent it for testing to Vaishno Devi.
So, sir, what factors were thought of to decide the diameter of the log?
So here, Gaurav, I was, very sort of, naive there. I just used the same log what they use, because I noticed that even if the Palki is broken or it is destroyed or it is removed from service, they keep the log. The log lives longer than the Palki. So I use the same diameter what they used. But I also noticed that in some locations they had an elliptical log. So we tried that elliptical log also, and it also always came with the convenience of the porters. So then I found out that the porters actually give logs from generation to generation. So the logs are available with them, and even the elliptical log, which has much wider location on the shoulder, is a personal choice of theirs. So they will choose what they want. So that's the reason I left it at that. So we didn't even specify what log to give. But when we manufactured the Palkis, we didn't supply with the logs. We just sent them the plain stainless steel Palkis. They got the rope and they got the logs, and we left it to them. Thank you very much for your attention.